Students, good morning, good evening and good night. Depending on which time you are going to observe this lecture. Welcome to the 8th lecture on electrochemistry. In this lecture we are going to discuss two very important aspects in this chapter. First, that is, we are going to discuss different types of conductors. So we can write different So in this lecture we are going to discuss very important thing in this chapter, electrochemistry chapter. That is, first we will discuss the types of conductors, and second we will discuss how to measure the conductivity of the ionic solution. Two things that we are going to discuss. In the previous lecture, in the lecture number 7, we have discussed to some extent about these different types of conductors. Now we are going to discuss in detail as per your syllabus. This is K. Mukherjee in the Science with Mukherjee Sir YouTube channel. There are basically two types of conductors you can see. Number one, that is the metallic conductors. Metallic conductors. What are those metallic conductors? That or we can say this is electronic conductors. Electronic conductors. Metallic conductor or electronic conductor. This is basically example of this, that you can see that metals or that is graphite rod or some polymers, modified polymers, they are able to carry the electrons, and in this metallic conductor you will find that it is the loose electron which is responsible for carrying out this current from one end of the conductor to the other end of the conductor. Now question arises, what are the factors that is going to impact these metallic conductors or electronic conductors? There are basically 3-4 factors that we are going to discuss. First factor that is going to discuss, it is the nature and structure of the metal and structure of metal. That is first factor. It is not like all the metals will have the same level of conductivity. You can observe that silver will have the highest conductivity. Then it is followed by different other metals, that is silver having the conductivity is around 6 into 10 to the power 3 Siemens per meter. This is for the silver. And whereas copper will have 1 into 10 to the power 3 Siemens per meter, that is copper. So why it is so? Why there is a difference in the conductivity between the metals? That is due to its nature and structure of the metals. Second factor, that is the number of atoms, number of electrons per atom. That is also a very, very important factor that is going to influence the conductivity of the metal. And the third one, that is the temperature. How temperature is going to impact the conductivity of the metal? If the temperature is increased, then conductivity will be decreased. What is the reason behind it? Reason is that when the loose electron leave the atoms, at the time what will going to happen? The atom will be positively charged, and this positively charged atom we call the kernel. And this kernel, when the temperature is increased, will vibrate, and when it is vibrating, it will restrict the flow of the electrons in its path, and that is why the temperature, increase of the temperature will reduce the conductivity of the metal. So there is a three factors that we understand. One, the nature and structure of the metal. Number two, the number of electrons per atom of the metal. And number third, that is the temperature. Now we are going to discuss another very important thing, that is the electrolytic or ionic conductors. Now we are going to discuss another that is second thing, that is ionic, or you can write it electrolytic conductors. Electrolytic conductors or ionic conductor. This is another very important thing that we have to understand. To understand this, let us understand the pure water. You will have the very less conductivity. Pure water, that you can understand, pure water, right? Pure water is very less conductivity, and its conductivity, it is observed, that is 3.5 into 10 to the power minus 5 Siemens per meter. That is a very less conductivity. Why it is so? This is because of the two factors. One factor, that is its amount of hydroxyl ion, and the H plus ion is very less, and it has been found out that as a particular room temperature, it is having the 10 to the power 7 moles per mole per liter. Very less amount of H plus ion or hydroxyl ion we can observe, and that is why pure water has a very low conductivity. But when we put some electrolyte in this pure water, what is going to happen? The electrolytes will dissociate into the ions. It will furnish its own ions, and at the time the conductivity of the water goes on increasing. And this type of conductivity by the ions, that is in the solution after dissociation, is called the electrolytic conductor. This is called the electrolytic conductor, and in this conductor you will find that there is a carry of electron, flow of electron by the ions. This is called electrolytic conductors. Now question arises, what are those factors that is going to influence the electrolytic conductors that we are going to discuss? First one, the factors. Now we are going to understand the factors for this electrolytic conductors or ionic conductor. The number one factor, that is the nature of electrolyte. First, that is nature of electrolyte. If the electrolyte is strong electrolyte, naturally it will going to dissociate with higher numbers of ions. Strong electrolytes will have the higher conductivity, strong electrolyte. As for example, 0.1 molar HCl solution have the conductivity, it is found around 3.9 Siemens per meter, whereas 0.1 mole acetic acid is having the very less 0.047 Siemens per mole. See, this is a weak electrolytes and this is a strong electrolytes, and that is why it is going to have the higher conductivity for this HCl and lower for the acetic acid. Second, that is very important, the size of the ion. Size of ion and its solvation is solvation. Size of the ion and its solvation. When size of the ion is less, at that time this conductivity will be higher, and when the solvation of the ions is higher, then it will have the lesser conductivity. You can easily understand if you say one solution of 1 mole HCl and 1 mole NaCl, if you take, then what is going to happen? The 1 mole HCl will have the higher conductivity than the 1 mole NaCl solution, because of the fact H plus ion have the lesser size than the Na plus ion. So here is size factor is going to impact. Now you can see another thing, that is the solvation factor. The solvation factors is going to predominate over the size factor. In this case you can find that Rb plus ion, K plus ion, Na plus ion and Li plus ion. If you see its size, you will find that lithium will have the lesser size, whereas sodium is greater than this, and rubidium has the higher size. As per if we go by this size factor, then lithium will have the higher conductivity. Lithium in the aqueous solution will be higher conductivity, whereas the rubidium with the lower conductivity. But practically this is not happen. Practically it is totally reverse, and this is due to this fact, the solvation. In this case you will find this, you can see this here, Rb plus have the, in the aqueous solution will have the higher conductivity, then potassium plus, then sodium plus, then lithium plus. In spite of the fact lithium has the lowest size. Why it is so? Because it is highly hydration. If we see the solvation or hydration, it will be highly hydrated. Highly hydrated. It is the number of molecules surrounded this lithium ion will be more than this rubidium ion because of its size. So its conductivity will be like this. So we understand the size of the ion and solvation, how is going to impact the conductivity. So we understand two factors. Number one, that is the nature. Number two, the size and solvation. And number three factors, that is again a very important factor, that is the type of solvent. Because it is, we are talking about the solution, ionic solution, and ions can be dissolved in any solvent. So type of solvent going to impact solvent. Type of solvent, or you can say, and viscosity. Type of solvent and viscosity, that is going to impact the conductivity of the ionic solution. How? If the solvent is polar solvent, at that time ionization will be higher. So at that time conductivity will be higher. Conductivity will higher. And it is the viscosity is higher. Viscosity is higher. Viscosity higher means is conductivity. Conductivity is lower. So you can easily understand, if the higher viscosity means what? That is the resistance to flow. it will not able to flow. The movement of the ions will be restricted for the viscosity. This is the third, fourth factor. Fifth factor, that is very important factor, and this factor we will be discussed in detail afterwards, that is concentration of the electrolyte. Concentration of the electrolyte is one of the basic, very important thing. How does the temperature? Temperature that we are observed in case of metallic conductor, what is going to happen? With the increase of the temperature, the conductivity decreases, but here it is conductivity, or you can say conductance, will be increases, because with the higher temperature there is a higher amount of dissociation of the electrolytes, and that will going to influence the conductivity. So here observe the 5 factors. Number 1 factors, the nature of the electrolyte. Second factor, size of the ions and its solvation. Third factor, the nature of solvent, into which we have nature of solvent and viscosity. And fourth factor, that is the concentration, that we will discuss in detail in later on the next lecture. And fourth, that is fifth, that is your temperature of the ionic solutions. So we understand the different type of conductors, that is metallic conductors and ionic conductors. What are the factors going to influence these two conductors? And now we are going to discuss its difference. What is the difference between these two conductors? Is there any difference? Yes, there is a difference there. That is, we can write, that is the metallic conductor, and ionic or electrolytic conductors. So metallic conductor, what is there? The flow of, we can write flow of current by electrons. The electrons flow, current flow from one end of the conductor to the other. Here flow of current by ions. This is cations or anions. Cations go to the cathode, anion go to the anode. That we will discuss in detail later on. In brief, the flow of current by ions in the ionic conductors. Here no decomposition is observed. No decomposition of the conductor is observed, of conductor. Here the electrolyte is decomposed. Electrolyte is decomposed. And third one, that is temperature increase, means conductivity decreases. Here third point, temperature increases, conductivity increases. So this is a 3 point which is going to differentiate between the metallic conductors and the ionic conductors. Okay, now we are going to discuss how we can able to measure the conductivity of a ionic solution. We can easily able to measure accurately the resistance of an unknown resistance by use of the Wheatstone gauge. But for the solutions, when you go to measure the resistance of the solution, it is not so simple, because when we flow DC current through these solutions, it will going to decompose. Number one. Number two, that liquid basically the solution is liquid. Liquid cannot be put as it is, like in the Wheatstone which we put the metals or in the solid conductors. So both the two problems has been avoided, has been resolved by two ways. Number one, DC current is avoided, it is use of the AC power supply. And number two, to keep the solution, a special design has been made. This is called the conductivity cell. Now we understand what is the conductivity cell. This is the conductivity cell. This is the conductivity cell. You can see here the solution has been kept in between these, in this vessel. This is called the conductivity cell. Conductivity cell. This is called the conductivity cell, and the solutions, ionic solutions that we have to measure the resistance of this, we have to put here. And there is a two electrode, you can see. This is the platinum electrode. This is platinum electrode, and it is finely platinum electrodes is being plated with a finely divided grinded platinum. So this is two platinum electrodes, and between these platinum electrodes the solution is being kept, and there is a connecting rod, and this equipment has been put here. This is called the Wheatstone beach. In the Wheatstone beach you can see this is the arrangement that we will discuss now in detail. First, let us understand conductivity cell. And this conductivity cell, the distance, there is a calculation in this that we need to understand. Distance between the electrode, distance between the electrode, suppose it is L, capital L, and there is a cross section of the electrode. Cross section of the electrode is suppose A. So what will be the resistance? So resistance, we know R is equal to resistivity into capital L by this. This will be the resistance of this ionic liquid, where you can assume this liquid is like a water, like a columns, like a liquid column. Ionic solution you can understand as a liquid column, and accordingly this we can able to understand this resistance, resistivity, length, distance between electrode and this. And we have to now this equation we have to correlate with the conductivity. How we know conductivity is basically the reciprocal of the resistivity. So we can now put here R is equal to 1 by K into L by A. So now we understand R into K is equal to L by A. Right? Now this equation also can be written in this way, that 1 by R, that will be discussed later on. Now we understand L by A. L by A is called the Cell's constant. L by A is equal to the cell constant. Right? L by A is cell constant, and it is represented by G star. So we can write this equation, RK is equal to G star, that is the cell constant. Now we know resistance is nothing but, if we want to correlate with resistance and conductance, so we can write 1 by G into K, that is a G star, and it will be coming around K. K means kappa, that is kappa is G dash G star into G, means the conductivity is the multiplication of the cell constant and conductance. So in the exam, this type of question we have to calculate the resistance of this solution from the Wheatstone bridge, and here this is the conductivity cell has been put. Conductivity cell is put here, and this is the Wheatstone bridge that you can see. This is a variable resistance, and this is another 2 resistance, R4, R3, and this resistance has been varied so that at the time when it is the balance, there is no electricity flow in this detector. So at that time we can write R2 into R3, that is equal to R1 into R4. This opposite will be, the product of the opposite resistance will be equal to the product of the other opposite resistance. So you can write R2 is equal to R1 by R4 by R3. So this is a relation, and these resistance are we know, and we can easily able to calculate the resistance with the conductivity. And when we know the resistance and when we know the cell constants, we can able to calculate this R. When we know the cell constant and when already we have calculated the resistance, then we can able to calculate the conductivity of the cell. It is K divided by cell's constant divided by R. This is the relation. Different type of matrix is going to come. That is all for today's lecture. In this lecture, we have discussed 2 very important points. Number 1, different type of conductors, and number 2, the how to measure the conductivity of the ionic solutions. That is, we understand the conductivity cell and Wheatstone bridge, how we can able to apply the Wheatstone bridge to measure the resistance, and accordingly we will be able to calculate the conductivity of this. Okay, hope all the points which I want to mention, which I want to convey to you, is clear to you. This is basically a service, free service to the students who could not able to afford any costly tuitions. They can take the help of this lectures, and you can find this lecture in the YouTube, and by simply typing the science with Mukherjee sir, and you can find all the playlist, and from the playlist you can go. Not only this, there is other subject. Then the class 11, all the points, all the lectures I have done according to the chapters, that you can go through this, and I am 100% sure that we are going to get lot of knowledge from it, and this will help you to make your dream true. Thank you very much for watching, and next we will discuss and the other topics that way. Okay, thank you very much.